So, with that, I would say join us by the fire and listen to the tales of how PowerShell security evolved through time. Before we start, we want to thank our sponsors. So, thank you so much. Hi, I'm Miriam. I'm a security program manager at Microsoft, and I wrote a book about PowerShell security and would also love to have Anam introduced.
Yeah. Hi, everybody. My name is Anam. I'm a software engineer on the PowerShell team. I work on security, PowerShell Gallery, PS Restores Get.
And actually, our journey together started this year at PSConf EU 2025 when we met in person in Malmö and decided, hey, we have to do a session together. So the content in my book and Anam's daily work aligned very well together.
A perfect opportunity. So over the course of this presentation, we're going to look at some of the security features introduced across the different PowerShell versions. And since PowerShell is such a powerful scripting language that lets you do a lot with different types of resources, privileges, different machines, it's important to consider security. So you may want to control which scripts, script blocks, or modules can be executed. With PowerShell, you may want to restrict the use of commandlets, types, and objects that could be used maliciously. You may want to determine if a script or module is trusted according to some metadata properties that it has. You may want to log and check errors for executed code. And you may want to know if a script payload is malicious before it's executed. So some of the features we're going to look at today take these security considerations into mind to basically help you secure your scripting in the best way possible.
And actually, everything started before. So we had different CLIs that were available, like Command-Com, CMD-exe. With that, although they allowed some kind of limited automation and command execution and bash scripting, they had incomplete GUI functions and the language was not very consistent. With that, in 1998, also Windows Script Host CScript.exe was introduced in Windows 98. And this enabled now COM API access and some more powerful automation. But also the downside was that it was exploited by malware very easily and was poorly documented. Also, other CLIs and emerged like Netsh and VMIC, and which led then to Jeffrey Snover joining Microsoft. Jeffrey Snover had a Unix background, and his vision was to actually bring the Unix tools also to Windows. But this was not particularly easy because, well, if you have already worked with Unix systems, you know that everything is text based. You have a command line, while if you work with Windows systems, everything is API based. And so this is not very easy to bring those two together. And Jeffrey realized that there is a new approach needed. And so, why is my okay now? So Jeffrey Snover started in 2002 Monad, or also called Microsoft Shell, and basically now the key innovations with that were that now you could pass structured data as an object through the pipeline. You could now execute remote scripts on multiple devices and also making the life of admins easier by simplifying all the tasks. But this was not enough. So on April 25th, 2006, Microsoft announced that Monad was now renamed PowerShell. And also in the same year, the first version of PowerShell was released. And not much later, in January 2007, also PowerShell was released for Windows Vista as well. Back then, it was still a standalone version.
Okay, so with V1, support was introduced to sign your script, check the signature of a script, and also the status of the signature. So here I have a signed script, and when I run get authenticate signature, I can see that it's valid. Signature is valid. If I check the signature of an unsigned script, I see that it tells me it's not signed. And if I check the signature of a tampered signed script, the status indicates a hash mismatch, which tells me that the script was signed, but the content was changed or something else was changed about it. And that kind of helps me understand the status of it.
That basically means that I can trust the script, right?
Well, let's
If
see
it was
about that.
tampered.
So, a script being signed alone shouldn't equal it being trusted. And that's because anybody could sign a script. So, the solution here is to use application control tools like AppLocker, for example, which was available with V1, to help create rules that determine if a script is going to be trusted or not, which was on the previous or earlier part of this demo. And from there, you can then understand if a script should be run in a restricted way or freely. So here I have a script for which I have a rule to indicate that it is trusted. And in this script, I have a call to add type, which would be restricted behavior if the script isn't trusted. So now if I go and I invoke the script, you can see that it ran freely. It was able to add the type for json.schema. But if I were to run another script that essentially has the same content, is trying to do add type, but it's not trusted by AppLocker, um, we'll see that the add type command in the script should be restricted, and I'll get an error saying that it cannot add the type. So it allows you, AppLocker allows you to kind of control what scripts are trusted or not and execute accordingly. Okay.
With version 1, also the execution policy was introduced. And many people mistook execution policy for a security control, which it is not. So in this demo, you see how easily execution policy can be bypassed. And basically, what execution policy is, it is a way to protect your users to accidentally run scripts by, for example, double clicking. So that means you need to have intent to run scripts. But it is not a security control. And you can see how many ways there are to just bypass execution policy. Also, with version 1, there were other features introduced. So, for example, the subject interface package, a component that defines how files of a specific files are signed and verified using Authenticode. Also, other Authenticode and certificate CMD-LEDs, as well as ACL CMD-LEDs. And with version 1, there was also some rudimentary logging introduced. So it was not that easy to configure. It provided a little bit of insight, but not the full transparency that you know and love from PowerShell nowadays. Additionally, there was also some protection that if you received scripts via emails, that they would not be executed by accident.
And then V2 was released in 2009, and this was included in Windows 7 by default. And with this came the introduction of PowerShell remoting. So you can run PowerShell commands on a session on a remote machine. And this uses WinRM at the moment. And for that initial authentication, it uses Kerberos by default. And in some situations, it'll use NTLM protocol as well. And then after that initial authentication, communication is going to be encrypted by WinRM for security. And then PowerShell also provides proxy commands. So, for example, we can see in the screenshot that these are some proxy commands that are available in a remote session. And what that does is it basically restricts the input for the parameter for the commandlet or what the commandlet can do, so that in a remote session, it's running in a restricted capacity and reducing an attack surface from overprivileged use or unintentional use.
And you remember when I just said execution policy is not a security control. Now with version 2, we introduced the bypass parameter. And with that, now it is possible to also intentionally bypass execution policy. Now they finally believe us when we say it's not a security control. You should not mistake it. But also with version 2, there was another feature added called add type. But as with all good features, there comes also a downside. With add type, you can also run a proprietary code or C code. And in this demo, you see on the right side, I'm typing in words, hello world, and you saw that my keylogger that I just added using add type just outputted all the code, all the characters now in my console or wherever I would have configured that to output. So add type might be very powerful for you to add more functionalities, but it could be also abused by attackers.
So some other security features that were included as part of V2 was support for event subscription and handling. There was support for transactions where you can group multiple commands together and ensure that all of those commands succeed, or if one of them fails, you roll back. There is also support added for modules and module security. So modules can be configured to respect execution policy, code signing, and run in restricted environments. There was also support for data language and localization, so you can support read-only data from script language.
And PowerShell version 3 was finally released in 2012 and included by default in the Windows 8 operating system. And my presentation does not like me to switch to the next slide. Now,
So with V3, a security feature that was introduced is constrained endpoints. And these let you configure a restricted environment for a remote session. So over here, I've created a configuration file. And for the constraint endpoint, I'm saying that the language should be in restricted language mode. And when I create that session and I've remoted into it, you can see if I run a command that's creating a variable and using that variable, that functionality is restricted and blocked because my remote session with a constraint endpoint is restricting it in restricted language mode.
do you know which is the all-time favorite version of attackers? Basically, it's version 2. Because in version 2, there was only a rudimentary logging implemented. And with version 3, there was module logging implemented. So basically here you see we have version 7 in our demo. You see module logging is enabled. And now we are running some commands. What is happening? Usually, if module logging is configured, then you would see it in the event log. And this is also the case here. But what attackers are doing, and why I'm saying version 2 is the favorite version of all attackers, is that they are performing a downgrade attack. So with that, you require Net Framework version 2, which you need to install. So it's not enabled by default. You can see here now, downgrade attack was successful. We are here in version 2. And if I'm now running all those commands that I ran earlier. By the way, in the meantime, I also cleared the event log so that you don't see the old events. And if I run all those commands and then switch back to my actual session. So I'm running get service, stop service, and then I switch back. And now what we would expect is to see actually the events. But since module logging was not available with version 2, and we just performed a successful downgrade attack, those events were not logged. And you would be basically going blind to an attacker in your environment. And also other good skill features like script logging or others would also not be possible with version 2. But I said PowerShell version 2 is not enabled by default anymore. You need to install Net Framework version 2. And in newer versions, actually, version 2 was removed, hard coded. So beginning August, September this year, you can't just perform a downgrade attack that easily on modern systems. It is still possible to download and install PowerShell version 2, but this is more complicated and not that easy, and you really need to require intent. So basically, don't do it. And my presentation is not the nicest today. It does not let me switch to the next slide. Okay. So with PowerShell version 3, there were also other new features introduced. For example, unblock file. So if you downloaded certain files from the internet, that you had to unblock them first before you could execute them, and also alternate data stream management. So ADS is a feature of NTFS file system that allows files to have multiple data streams. So if, for example, a file is accessed and cannot be opened, that means that there is already a data stream. And now with the new features, admins can just inspect and remove streams that could block execution or hide malicious content. Also, the initial constraint language was implemented. And you saw it in the demo earlier. There are now also registry settings available for module logging.
Okay, and then in 2013, PowerShell v4 was released, and this was included in Windows 8.1 by default.
And since this version was only released 1 year after the last one, there are not that many features available. But one really great feature that was made available was desired state configuration. So desired state configuration allows you to define or to declare the configuration of your machine that you want the machine to be in. And like this, basically, the machine could also self-heal itself. And you had different operation mode. So, for example, if you configure DSC in push mode, that means you have to constantly push your configuration to machines. But if you configure it in pull mode, the machines pull the configuration. They say, hey, can you please give me the latest configuration? What should my configuration look like? And then they pull the configuration and apply it. So basically self-healing, which makes systems a lot more secure and also protect them better from tampering.
And then v4 also included some other security features. So it added support for workflows where the state and data of the workflow is saved and it's persisted at certain checkpoints. There was also improved security for PowerShell web services. And with KB3000850, security features of the future version v5 was also be able to be backported to v4.
Anam, do you know what my favorite PowerShell version is? And I tell you, it's not version 2.
Not the attacker's one.
No, it's version 5. Because with version 5, which was released, by the way, in 2015, and included by default in Windows 10. Most security features that we now know and love today were introduced in this release. So I found this version to be one of the most exciting PowerShell versions ever.
Yeah, and with this version, we got support for script block logging. So if you have a script script code that's running either raw or obfuscated, in the logs, you can see what it looks like deobfuscated. So this adds some transparency. So here I have script block logging enabled, and I have a command get child item, which I'm going to encode, and we can see the payload for that in a second. Okay, and now if I invoke this encoded command in PowerShell, um, we can see that it runs. But then if I want to look through the logs and see if I was able to get the deobfuscated script block that ran, I am able to do that. So I'm going to request the event logs with code 4104, which is the one for script block logging. And then I'm going to get the events related to that. And it returns a couple of events, but the one that I'm looking to show here, um, okay, here we go. So you can see that get child item was ran and the logs capture it deobfuscated, which is great to see and get transparency from. And Miriam actually has a great script for this called get executed code, which will link in the resources at the end. But you'll kind of see that multiple different events were kind of created surrounding this one uh, script that was ran. So it kind of helps put it all together and display it more easily back to you. Okay.
With version 5, there were also the language modes introduced. So basically, you can have the full language mode. This is the default. That means you can run everything. Then you have the no language mode. This can be used via API only and allows no single kind of script. And the restricted language mode is actually not intended to be used explicitly in most scenarios, but uh, when you're working with localization files. So localization files actually store translated text strings that can be used to write multilingual scripts. And last but not least, also constrained language mode. With constrained language mode, it is not possible calling arbitrary APIs or adding custom C code with add type, like you saw before. You can also not just run COM objects. And in this example, you see that I'm trying to call an arbitrary API to write hello world. But now with constrained language mode configured, this is not possible. And if you remember our demo from before, where we used add type to actually run a keylogger in PowerShell and to capture all the keys that were typed. So in this scenario, or in this demo here, there is no constrained language mode. And now let's see what happens when constrained language mode is enabled. And basically, add type is not even allowed. And so the entire demo fails and cannot be executed. Another really cool feature that was introduced with version 5 was AMSI. And basically, AMSI hooks itself between PowerShell and the operating system. And before any code is executed, it is sent to the antivirus for inspection. And if the antivirus considers the code as fine, as clean, then the code is run. But if not, it is blocked. The code cannot be run. And of course, also the behavior is locked, not all in any case. And for example, if we are trying to run invoke mimikatz when AMSI is enabled, then it is blocked and cannot be executed properly.
So with PowerShell v5, there was a big focus on security, especially with security transparency. So there were improvements to module logging, introduction of script block logging, as we saw. And if you wanted, or if you were logging sensitive information, there was support for protected event logging for that, as well as support for transcription. We also introduced just enough administration, or JIA, which restricts what a user can do in a local or remote session to reduce the attack surface. And if you know Miriam, she loves the opportunity to talk about or present about JIA, so we decided to take a break from that this year. But yeah, and there was also support added for cryptographic message syntax commandlets, and then security modules like revoke obfuscation and injection hunter module were created by Lee Holmes and community members. So a lot happening in terms of security, right, Miriam?
Yeah. So absolute favorite version of all time. But with PowerShell version 6, no, there was a huge change. So it was initially released as a standalone version in 2018, and now the PowerShell team was mostly focused on the effort to make PowerShell available cross-platform as open source software. So basically, to offer full security transparency, PowerShell version 6 introduced the first macOS and Linux PowerShell shell. So with that, we did not only have now support for Linux and macOS, but also syslog was integrated so that logging was more transparent and cross-platform. And also SSH remoting, while we only had WinRM before.
Yeah, so with V6, we got PowerShell remoting support with SSH, and this lets you remote into a Windows or Linux machine with SSH. And you can see that the new PS session commandlet that we were using before for remoting now has SSH related parameter sets. And when I run new PS session, I can use the SSH transport parameter. And then I can remote into the session, and the host name reflects that of the remote session or remote machine session on the right, and the remote machine is using OpenSSH. And in this example, I did password authentication, but with SSH, you also have support for key-based authentication. So, yeah.
And now finally, the current version that we're working with was released in 2020, PowerShell version 7.
So before we talked about application control with App Locker, but with PowerShell 7, WDAC is the focus, and it's also the recommended application control. So here I have WDAC configured, and I have a file rule to trust demo.ps1, and we see that demo.ps1 takes a parameter of a certain type. But if I try to create a hash table and pass that in when I invoke the script, PowerShell is not going to be happy with that. And that's because when PowerShell is running with WDAC, it goes into system lockdown mode. So it's a bit more restrictive in how it works with WDAC. And since if you pass in a hash table and it tries to convert it to a type, there's possibility for data exfiltration. PowerShell will restrict this in lockdown mode. Okay. Another thing that PowerShell will restrict in lockdown mode is dot sourcing across trust boundaries. So here I have a file, helper script trusted, which has been trusted with my WDAC rule. And then this is helper script trusted, and you can see that it's calling add type, which requires that the script be trusted for it to be able to run that command. And then I have this script, which is untrusted, and it's dot sourcing my trusted script and then trying to call the function from the trusted script. And when we run this untrusted script, we're going to see that PowerShell in system lockdown mode is going to restrict this because you can't dot source across trust boundaries. And it does this so that code that's defined in a trusted scope can't be pulled into an untrusted scope and expose information that way, or expose functions that way, rather. Another thing that PowerShell will restrict in lockdown mode is dot sourcing with wildcards. So here I have a script module file and that's configured to be trusted with WDAC. And I have this script file that defines some functions. And in my PSM1 file, I dot source that script file, and then I define some more functions. And at the very end, I'm trying to export all the functions in my scope with a wildcard. And when I try to import this PSM1 file, we're going to see that PowerShell restricts this behavior in lockdown mode because you're exporting functions with wildcard while also dot sourcing. And the idea here is that you would just be exposing too much unintended code possibly. So this kind of pattern is restricted. Okay. And then with PowerShell 7.3 and onward, I believe COM object creation was also restricted in lockdown mode. So I have some WDAG rules configured here, and the script is trusted. But when I try to create a COM object, it's going to be blocked because COM objects can expose Win32 APIs that may not have been hardened as rigorously, so that could contribute to an attack surface. And we can see when we ran the script, PowerShell restricts that in lockdown mode as well. Okay. So some other security features that I guess have come out with V7, and keep in mind that more will come out as time goes on. So with 7.3 and onward, there is support for the new WDAC API, and this basically allows more granular control on how you're dictating trust be set for certain files and how it should act. Basically, if it's decided that it needs to be run restrictively. There's also support for app control policies in audit mode in 7.4 and onward. There is support for SBOM creation, or I guess PowerShell is producing SBOM with 7.2 and onward, and this is just a inventory basically of all the components, libraries, and dependencies of the software. So it adds more transparency into what PowerShell is being packaged with. And then there's also extended AMC support for all .NET methods and 7.3 and onward for that. So more methods are being analyzed by AMC. Then there is also secure data transfer and PowerShell remoting with the 7.6 preview 5. So a lot that's coming out, but also more will also come as PowerShell V7 is, getting new releases and such. Okay.
And with that, we are already at the end of our journey. So a lot of good things happened in the past. A lot of great features were introduced. But also going forward, security is always evolving. And it is a constant cat and mouse game between attackers and defenders. And Anam and the rest of the PowerShell team will also evolve and defend PowerShell, implement new security features to protect you and the PowerShell world. And what you can also do to protect yourselves better is get the latest versions. Don't use PowerShell version 2, also not on purpose. Install security updates. And do not only trust your WSUS, but also double check against the catalog. Use the extensive logging features that PowerShell offers. We have so much good logging stuff in there, and review the logs. And last but not least, be mindful of security. Always have a secure mindset when you work, also when you interact with others, and also if you interact with possibly users. And with that, thank you very much. If you have any questions, Anam and I are here. And those are the helpful docs that Anna mentioned earlier.
Yeah,
Thank you.
we tried to cover some of these security features, but there's a lot more nuance to it too. So feel free to take a look at these docs or refer to them as kind of starting point for, what's working or what's going on in them.